All right, at this time, open up in Schoology the Notes Part 2. And we're going to basically work off of these slides for Notes Part 2. I'll fill in any missing parts of Notes Part 1 when we meet again on Monday. All right, so 14.3 is going to focus on a lot of topics that we've already covered. Talking about soil formation, talking about weathering, erosion. So I've actually scaled back a lot of the notes here. So I'm going to recap them, and then we're going to get right into 14.4, which talks about different types of desert landscapes. So here we have weathering, erosion, and deposition in deserts. So weathering in the desert is going to be primarily physical weathering. The reason being is we don't have a lot of water, and we know that water is critical for chemical weathering in order to get the oxidation, in order to get the hydrolysis. So this results in a desert landscape being very crummy. And I use that word on purpose. If you think about a loaf of bread, right, when it dries out and then starts to break down, we got all these crumbs all over the place. Because we're in a dry environment, because there's low precipitation, rocks are not going to be dissolving and being washed away the way we would in temperate climate, like where we're located. And so as the water gets in there from dew, from rain, because there is moisture in the desert, right? Let's always remember you can have precipitation, it's just less than 25 centimeters per year. That water will actually break down just specific minerals, and we're going to leach them. Now remember, leaching was that term that we used with drawing ions and washing minerals down into the soil. When we did soils, well, here we're actually going to leach the minerals out, and it causes the structure of the rocks to basically break down and crumble. If any of you have watched any movies about like Arab countries, war movies, you see a lot of these desert scenes, and it's always very, very bland, but it's also very, very rocky, pebbly, and we're going to see that landscape coming in the next section. So up here we have desert soils do not have an O horizon. If you recall, the O horizon is the organic layer. We opened this chapter saying that deserts, by classification, have less than 15% vegetation. So if I don't have a lot of vegetation, I'm not going to have an O horizon. All right, hate to state the obvious, but it's always good to put it in there. Now down here it says, furthermore, calcite doesn't wash away entirely, but rather accumulates and precipitates beneath the ground surface. Now, having been over there in the desert, we were actually filling sandbags one day, and as we were digging down, we were getting these clumps of rock. But you can actually see the calcite bonding in there and making these chunks of rock. So I left the note in there. I think more as an interesting talking point. Don't stress your mind around that one. All right, next slide. So, desert soils develop slowly, and going back to that low precipitation, if we don't have a lot of plants, if we don't have a lot of chemical weathering, it's going to take a lot longer for rocks to break down. At the same time, because we don't have this cohesion with the water, we don't have things sticking together, it's very hard to accumulate sediment on a steep slope. So when we get to landscapes, you're going to see cliffs are a really big feature, right? Sharp, angular edges, big feature in the desert. The second bullet here says deserts commonly contain rocky escarpments. Now, escarpment may seem like a weird word. You guys can obviously Google it, but basically it's bringing up that idea of the cliff face and the sharp transition. And then you also are going to have the ground covered with pebbles, cobbles, boulders just littered around. You don't get the water washing it away. You don't get the rivers washing it. Instead, as things break down, there a lot of wind erosion going to take place, so it leaves this very marked landscape. And then down at the bottom, we have desert varnish. Right, so as the wind blows across the desert, it's going to carry with it sediment that's clay. Clay is very, very fine. And even the wind-blown sediment, like went through a sandstorm, and the sand's kicking all around, it's very, very hard to see. But when the winds actually settled down, you didn't even notice that there was a film on all the surfaces until you took we used to take our ID card and we would scrape the top of the table. And what looked like just a clean table suddenly had this really, really fine pile of sediment. Well, that wind-blown sediment, in the case of clay, will actually make a film on rock layers, and that's what we call a desert varnish. I'll explain more with pictures on Monday. All right, on to what I want to really get into, which is desert landscapes. So desert landscapes, number one, not going to have a lot of plants, right? We typically think of deserts as just like long, huge tracts of flat land, lots of sand. But these cliffs, these rocks, also incorporate themselves into the landscape in a very unique way. So let's get into it. So rocky cliffs, mesas, and arches. Where we have this desert landscape and it drops off very quickly. This is what we refer to as a rocky ridge or cliff. This occurs because of the physical weathering that we mentioned at the beginning. You don't have the water breaking things down. So when you do get water and jointing, cracking, the rocks are going to break and then crumble. Break, crumble, break, crumble. And over time, this creates a very rigid landscape with a retreating cliff face. So the rocks break off and fall. And then almost like if you remember, we talked about waterfalls and the fact that the rocks fall and the waterfall moves upstream. Well, in the same way, just on a vast plain, you have rock face falling, rock face falling, rock face falling. And that's what's going to create this cliff retreat. And with cliff retreat, we look at three different landforms. One being a mesa, one being a butte, and the smallest actually being a chimney. So in your notes, you see a picture. It looks like this. And you can see the progression as the land keeps breaking off and falling down. All this vertical jointing that you see in this picture. Right? All this vertical jointing. All right, that is a terrible color to use, right? Over in here, and here, and here. And then think about it as it moves back, right? Each layer breaking off and folding down. Just going to pause for a second. Is that not an awesome picture? Right? To me, that's the stuff that earth science is all about. Not all the notes. All right. So, stony plains and desert pavement. So, stony plains, right? This idea that the land is just covered with cobbles and pebbles and rock, again, not being washed away by water, not being drawn down into streams and churned into river rock. Instead, very angular, very crummy. I'm going to keep using that word crummy just to beat home the point. So when we talk about a desert pavement, right? Pavement is a term we use for walking outside and you have a patio or asphalt, right? That's the pavement. So what does the desert pavement or the surface actually look like? And they use the tile mosaic idea. Think about the rocks actually breaking in this flat plane, but you get this cracking and blocking effect. And that's really driven because of the sun. Right? The heat of the sun dries out the rocks and causes the rocks to basically shrink and crack. So the idea of heating and cooling, break down the rocks. So again, physical weathering, not chemical weathering. I'm going to stop talking for a minute just so that you guys can fill in the notes. If I've gone too fast on something else, this video will be up for a day or two, so you can always go back and watch it, or I can fill it in on Monday with you. All right. So, my most favorite part of the whole desert, dunes. Absolutely most favorite part of the desert. Just a little backstory for you. 2005, I'm flying across the desert in a Black Hawk, doors open, staring out into the desert. And I'm looking at the different landscapes. I'm looking at the cliffs when we're going down the Tigris-Euphrates. We're flying out over the open plain as we're going from base to base. I'm seeing these different dunes, and I am totally perplexed. I took earth science. As I told you guys, I did not like earth science. So I didn't actually understand what I was looking at, but that curiosity, wanting to understand why the landscape changed like that so abruptly, why we had cliffs here, drove me back to science. So the reason you're getting tortured by notes right now very much has to do with dunes. So please dislike the next few slides, or maybe open your eyes a little and see that curiosity. All right, enough about me. So local wind patterns will build and accumulate sand in the desert. And we're going to look at 5 different patterns of how this actually plays out. So when we talk about sand dunes, we're talking about long piles of sand. Just so you know, that sand is actually oftentimes very, very rounded, because when wind blows sand, it actually moves faster than water, and therefore it weathers down the edges so much faster. One of those things that I just thought were fascinating when I had the time to look at it. So, how does this process work? Well, the sand grain comes along, it's flying along, and it hits an obstacle, an obstruction, something that stops the grain. And so it starts to collect there, just like snow. All right, when the snow's coming across, blowing across your front yard, and then it hits your car, it starts to pile up. And then on the other side, there's no snow. Well, in the case of a dune, right, the wind blows the sand, it hits the object, and now it starts to roll up and drops off. Rolls up and drops off. Rolls up and drops off. And it keeps cresting over the side on what we call the windward side. And then when it drops off, we call that the leeward side. So the leeward side is where you're actually going to get the buildup of sediment at the angle of repose. I know, third chapter, I'm using the word angle of repose. I told you it was important. That's why I put an exclamation point after it. So the material comes up, comes up, comes up, drops off, drops off, drops off. And that pattern of material sliding down is why we call it the slip face. So leeward side of dunes, slip face. I'll pause, you guys fill in what you need, and then we'll actually look at the picture. Because sometimes a picture is worth 1,000 words. All right. So, if you look down here at the bottom, right over in here, you're seeing how the grain is bouncing up. Remember when we have bouncing grains? Just like in a river, we call that saltation. And then, once it crests over the top, this right here is your slip face. So bounce, 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 slip face, bounce, 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 slip face. And what's really cool is there are examples in rocks all over where the winds can actually change direction. So for a while you get this pattern, and then you might get this pattern, and then you might get this pattern, and then you might get this pattern. Just so you know, those rocks are usually a little expensive to purchase. So I don't have any in the lab. But I will certainly show you guys some pictures on Monday. And it's showing the direction that the wind blew and then where the accumulation was. The bottom of this picture is actually trying to show you that transition, and that's why it says main bedding across the bottom right here. All right, now 5 types of dunes. Anybody see like diagram on test? I don't know. Definitely the first thought that popped into my head. All right, so over here we have the Barcane Dune. The Barcane Dune looks like a crescent or a croissant. Over here is the transverse dune, and the transverse dune is going to form basically perpendicular to the direction of the wind blowing. Over here, the star pattern, as you see, you got the star. This is because you're going to have varying directions in the wind. Parabolic, as you're going to see in the notes, is actually when the wind pushes so hard that it breaks through the transverse. So a really strong wind, transverse, now becomes parabolic. And the last one down here is longitudinal. And longitudinal, long and parallel, remember math, parallel to the wind direction. I know, you don't have anything to write, so let's get to the slide you have to do a lot of writing for. Ho, there we go. So Barcane Dunes, right? Beautiful crescent dunes. And the crescents point downwind. Star dunes, right, are going to point out in all different directions, and it's because of the the frequent shifting in wind direction, or variation in wind direction. And then transverse dunes, when we say wave-like shape, think about the waves rolling in when you're at the beach, right? It's a long linear feature, but it's moving toward us as a wall. The dunes basically form in that same pattern. And you guys have the diagram in your notes, so just take a look at that, maybe make little notes of the key feature for each one of these types of dunes. While they're finishing up, to my colleague, thank you very much for covering class today. I really do appreciate it. All right, so we got 2 things we got to talk about: parabolic and longitudinal. So in the diagram I just showed you, you saw that when the wind breaks through the transverse dune, it creates a parabolic dune. So here, the points point upwind, as opposed to when you looked at the Barcane, the points pointed downwind. So I think about a Barcane dune like a bull, right? It's charging forward and those horns are out. Parabolic, right, is pointing back. I think of it more like a boomerang, right? If you're throwing a boomerang, right, the points are angled back. If that helps some of you, great. If it doesn't, just memorize what the notes say. And then longitudinal, long, linear, and the key word here, parallel. Right? It's parallel to the wind. So I definitely think dunes would be a great diagram. Sometimes I go back and forth. Do I want to just make it a straight diagram, or do I want to put pictures on a test? So think about those things. We'll discuss it a little bit more on Monday. Tuesday, I definitely plan to do a quiz on the first section, because from here we're actually going to get into glaciers. So I want to make sure that you guys are rock solid. But this weekend, spend some time, read down your notes. Those of you that are looking to improve, read down your notes. Write out what maybe you're not recalling from class. And lastly, we're skipping over 14.5, but there's one point that I would be remiss if I didn't touch on, which is desertification. And where we look at an area and say, okay, well, it has really low precipitation, therefore it's a desert. We also have regions in the world, and if you're really interested on this, you can read through this section. But when we have natural droughts, right, long periods of an unusually low rainfall, when we have overpopulation, you know, that this whole idea of too many people, when we have overgrazing, right, when we misuse the land, intensive farming, right, where they're not using good farming practices, and the diversion of water. So if we're taking water out of an area, all issues, by the way, that we have in the U.S., and we'll get into some of those political conversations at another time. But when we run into these situations, we can actually dry out the land. We can actually create a desert environment in a matter of years or decades. So you draw water out of an area, you're going to have some issues. When you have too many people using the water in an area, you can have some issues. And I think the biggest one that your generation is going to see is as climates start changing, we're going to get more varied weather, and that can also lead to things like natural droughts. So if we have changes in wind patterns, if we have changes in precipitation, you may start to see more desertification. All right, with that, I'm going to stop. You guys are going to go ahead and start your homework. So you're welcome. and I hope you guys have a great weekend. I look forward to seeing you guys on Monday.